Okay, so the last thing I said, besides next video we'll finish up the problem, and again, I can't emphasize it enough because I see it all the time. That negative 2 has to be in parentheses to square it correctly. Now, next thing I'm going to emphasize when we simplify this here, that's going to be 2 plus or minus 4 minus 8 over 4. Nothing cancels. The 2 and the 4 there do not cancel. And so I'm going to get 2 plus or minus the square root of negative 4 all over 4. This is imaginary right here. And we saw it in the first problem, and now we're seeing it again. That tells us no x-intercepts. That when we're doing things graphical, when you're doing graphical features, you just can't use imaginary numbers at this level. Yeah, if you want to go take Math 7000 or so, there are things you can do, but at this level, we're not using imaginary numbers when we're doing things graphical. No x-intercepts. So now finishing this problem, finishing it up, going on another piece of paper. Now we did need to know the axis of symmetry. And that is always x equals the x-coordinate of the vertex. And so that's going to be x equal 1/2. And now we're ready to graph. To graph. And my function was f of x equals negative 2x squared plus 2x minus 1. A is negative 2, so that's less than 0, so it opens down. Then stuff we knew. We know that the vertex was the point 1/2, negative 1/2. We knew that the y-intercept was negative 1. So, vertex. There's 1, there's negative 1. So the vertex was 1/2, negative 1/2, right about there. The y-intercept was negative 1, and then the parabola opened down. There it goes. There's a good enough parabola. Domain. As we've said each time, the domain is always for all parabolas, all quadratics, negative infinity to infinity. The range is always your lowest y-coordinate to your highest y-coordinate. Well, it's going down forever, so lowest is going to be negative infinity. Then my highest is going to be that vertex point right there, which is 1/2, negative 1/2. And so my highest y-coordinate is negative 1/2, and it gets a square bracket. And there's our last graphing problem for today. Going to move on topics a little bit. Still going to be about quadratics, because that's what this section's about, quadratics. But we're going to move on a little bit is what this a value tells us. And what we already know, it tells us that it opens down or up, as the case may be. In this problem, since a was negative, it opens down. And so that automatically tells us something about the vertex. That when my parabola opens down, this vertex will be a maximum. If the parabola opens up, it will be a minimum. So you can tell before we actually graph the parabola whether you're going to have a max or min. If your parabola is going to open down, if a is negative, you're going to have a maximum. If your parabola opens up, like it did on this problem here, where A was 1, it opens up, you've got a minimum. So just looking at that A value, you can determine if you have a maximum or a minimum. And that's what it says on this next page. Imagine that. The above parabola's vertex was at the top of the graph. The vertex was a maximum. Note in the problem above, as I already said, but we'll say it again, A was -2 or A was less than 0. So when A is 0, the vertex will be a maximum. Similarly, when given a quadratic function with A greater than 0, typo here. I wonder how long there's been this typo. And again, when we find the typos, I can't promise that when you download these notes that the typos will be fixed, but there is a typo. When A is less than 0, that's this guy right here, A was less than 0, we will have a maximum. When A is greater than 0, typo here, big typo, minimum. Big old typo there, big old typo. I would like to say I'm going to run to my office and fix that, but I'm doing, like I've said before, I'm lecturing to an empty classroom in anticipation of whatever might happen in the fall 2020 with the pandemic. I'm lecturing during summertime to nobody. It's summertime. After I finish doing this video, or these videos for this section, I'm going home, so I'm not running to my office to fix this. But hopefully I will fix it someday. Just can't say when I'm going to fix it. But I completely digress there, so let's kind of pretend none of that happened. If A is less than 0, you're going to have a maximum. If A is negative, you're going to have a maximum. If A is greater than 0, A is positive, you're going to have a minimum. So let's do this problem here. An equation of a quadratic function is given. Do the following. So there's my function. Determine without graphing whether the function has a maximum or minimum value. So it's all about the A. A is 2. Now it's not important that it's 2. What's important is that's greater than 0, it's positive. That's what's important. And so the basic graph looks something like that. And honestly, that's what I remember. I don't remember, okay, positive, minimum, I don't remember that. I remember what the graph looks like. That's what the graph looks like. And so we have a minimum value. I just remember what the graph must look like. If that looks like that, you've got to have a minimum. Find the minimum or maximum value, determine where it occurs. Okay, the minimum value, and this is a little nitpicky language, is the y-coordinate of the vertex. Where it occurs, x-coordinate of the vertex. So I just have to find the vertex. So find the vertex. So x equals -b over 2a. We'll use that format. So -12 over 2 times 2. And what, that's 12 over 4 or 3. So that's where it occurs. Then my y-coordinate is going to be f of 3. So plugging 3 into my function, so 2 times 3 squared minus 12 times 3 plus 3. So it's 2 times 9 minus 36 plus 3. 18 minus 36 plus 3. And what, that's -18, -15. And so there's my minimum value. Where it occurs is your x-coordinate. Your y-coordinate is the actual value. So there's where it occurs. Can't really read that, can you? So that is where it occurs. And the actual value is negative 15. Then determine the function's domain and range. As we've said every single time, domain for all these quadratics is negative infinity to infinity. Then just the basic graph. It's going to look something like this. That we know it's a parabola that opens up. So it looks something like that. And we now know that that point there was 3, negative 15. That's, just an absolute basic graph of this guy. That we knew it was a parabola that opens up. Then we found that the vertex was negative 3, 15. So my range will be negative 15 to infinity. My lowest point, my lowest y coordinate, to my highest, but it goes up forever. And so there's my range. And again, this could be checked by graphing it. Okay, so we're going to finish up with a few word problems. I know no one likes word problems, but that's what we're going to finish up with. And we'll get the first one started on this video, and then we'll finish it on the next video. We'll get a picture maybe going on this one. You have 200 feet of fencing to enclose a rectangular plot that borders on a river. If you do not fence the side along the river, find the length and width of the plot that will maximize the area. What is the largest area that can be enclosed? Okay, so we've got a river. There's my river. And it says we're going to enclose a rectangular plot. So there's a rectangular plot. And in the end, it says find the length and width. So let's call this L, and let's call that W, and that has to be L there. And I want to find the length and width. Okay, so there's my picture. Now trying to interpret what all this stuff says. I have 200 feet of fencing. So what that means mathematically, so L plus W plus L has to equal that 200. That the fencing are all those, the length and the width. And so 2L plus W equals 200. So there's one piece of information we have. And then it says find the length and width that will maximize the area. Well, let's at least get an equation for area. Well, we all know that area is length times width. Okay, so this is really strange. I mean, I got this over here, I got this. These are all L's and W's. What this is called is an optimization problem. And what we need is we need a formula over here in terms of one variable. And so this guy up here, I'm going to solve this for W. So W equals 200 minus L. And then I can take that over here, and we'll see why we did this in a minute. So I can just bring that over here. And then I can multiply this out. And if you don't like L's and W's, feel free to use X's and Y's. I just went with L's and W's because we got length and width. And notice, this guy right here, exponent of 2. And let me rewrite this again one more time. Let's just put that guy up first. It's a quadratic. This guy right there, A equal negative 2, less than 0. The vertex will be a maximum. Well, that tells us something very important that we'll hear on the next video.